Hello and welcome back to part 3 of AP Calculus BC 2016 exam. In the previous video we did part B of the multiple choice section, and let me tell you, I was really silly. As you notice, I just said 2016 practice exam, and as it turns out, 2 weeks ago was when I took the 2016 practice exam on my own, which is why some of the questions were seeming oddly familiar. I hope that doesn't discount some of the scores I was getting, because it was genuine thinking and I wasn't primed. But, yeah, duh, I did the 2016 exam before. So, I'm going to get us to the 2017 exam, which I definitely haven't done. And we're going to keep the multiple choice. I would prefer not to redo all of that, but we're going to do the free response questions on the 2017 exam, which I actually won't have done, which is nice. So I will see you on the new exam. Haha, well, I found the 2017 free response questions, so I don't know, the full exam maybe is not quite available yet. I'm not sure. Anyway, so let's just look at the very bottom here. We have section 2, part A, 30 minutes of time, 2 questions. Calculator is required, as we can see here. Graphing calculator is required for these questions. So I'm going to get my calculator out of its case, set ourselves a timer for 30 minutes up here in my other window, and at the same time get rid of some layers on my drawing program. So sure, we don't really need 5 seconds, do we? Alright, so now let's get rid of this and make a new thing. Alright, time to get into section 2, part A, free response questions from now the 2017 exam, because I have no memory apparently. I'll get the questions, well, we won't actually do a list of questions this time around because we're going to be writing them out section by section and actually doing writing work, so we won't need to do that quite so much, although I'll try to keep it slightly orderly. So let's say that the left side of the page is where I'll write numerical answers, and the right side of the page is where I'll do my work. Okay, go! A tank has a height of 10 feet. The area of the horizontal cross-section of the tank at height h feet is given by a function a, where a of h is measured in square feet. Function a is continuous and decreases as h increases. So that means your area is going down as height goes up, so your tank is maybe going to look something like this. Boop, boop. Okay, select values of a are given in the... Okay, so, for example, at no feet, which is, say, at the ground, you have 50, and by the time you're at 10, you have a very small area of just 2.9 feet. Okay, well, question A asks us to use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank, indicate units of measure. Alright, well, the volume of the tank is going to be the sum of all the areas, so it wants to use us 3 subintervals, not necessarily of equal length, obviously, because it doesn't give us equal length. Excuse me, hiccups. So here we're going to say first we have change in 2 feet, so we can say volume approximately equals, so 2 feet times, and then a left Riemann sum, so we're going to say 50.3, 2 times 50.3, plus, and now we have a difference of 5 between 2 and 5, sorry, 3 between 2 and 5, so that times 14.4, plus a distance of 5 between 5 and 10, times 6.5, 6.5, not 65. Alright, and this is all going to be in cubic feet by the time we get to the end of it, because we're multiplying feet by feet squared. So, here we're going to get 100.6. Here we're going to use a calculator so we don't mess up. It's 3 times 14.4 gives us, oh, not 3 plus, 3 times 14.4, 43.2, plus 5 times, okay, that's just going to be 32.5, but just check 5 times 6.5, 5 times 6.5, thank you. Yes, okay, that's correct. So this is going to give us, we're approximately equaling here 100.6 plus 43.2 plus 32.5, bada bing bada boom, 176.3 cubic feet. So let's write this out that this is question 1A. Volume is approximately 176.3 cubic feet. All right, so that looks like it'll work. All right, does the approximation in part A overestimate or underestimate the volume of the tank? Explain your reasoning. Well, it's all right. Well, as we know, area is decreasing constantly, so we're going to be overestimating because we're using an estimate that's going to stay the same high as the actual area is decreasing. So part B is going to say, and let me actually write in a different color so it's easier to see. Our approximation is an overestimate because, just a second, I forgot to stop the timer as I did the recording there, as pause the recording. Anyway, we'll just take it as an overestimate because the area A of H is decreasing. Boom. Okay, that should be enough, right? It's decreasing. Yeah, okay. So, it's decreasing, and we're using a left Riemann sum, and we are using a left Riemann sum, which means that we're going to be taking the overestimate. Okay, that's pretty good. Alright, the area in square feet of the horizontal cross-section at height, h feet, is modeled by the function. Alright, so now it's actually giving us a function to work with. Based on this model, find the volume of the tank, indicate units of measure. So, if this is the actual horizontal cross-section, we can just take the integral from 0 to the total height is 10. So, this is going to be the integral from 0 to 10 of 50.3 divided by e to the 0.2 h plus h dh. Alright, let's plug that into the calculator. Integral from 0 to 10. Sorry, I wrote it kind of sloppily as well to speed up the whole process. So, 50.3 divided by e to the 0.2 times h plus h dh. Alright. This approximately equals 101.325. And that is, of course, going to be in our cubic feet. So, let's write this in. Okay. Maybe yet another new color. So, given f of h, volume approximately equals 101.325 feet cubed. Okay, perfect. Water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at a rate of 0.6 foot per minute. That should be feet per minute. Sorry, grammar nerd. Anyway, using the model for part 1, and I just got the thought. We want to finish up this question by 15 minutes, so we have 15 minutes for the second one, and if possible, even sooner. Just budgeting time. Sorry, random thoughts. The height is increasing at a rate of 0.6 feet per minute. Using the model from part C, find the rate at which the volume of water is changing with respect to time when the height of the water is 5 feet. Indicate units of measure. So, what it's asking is this related rates here. So, find the rate at which the volume of water is changing with respect to time. So, it's asking for dv dt. Alright, so what it is asking for is the change in volume with respect to time at when height is equal to 5, given that water is being pumped in here. Water is being pumped in at 0.26 feet per minute, which tells us that we're going to multiply our unit change by 0.26 feet per minute. So, so, right, okay. Find the rate at which the volume. So, what we want to do is we're going to say the square cross section, so A of h, so F of h. So, we're going to find what is the area at 5 feet, which is going to be 50.3 divided by e to the 0.2 times 5 feet up plus 5 feet up. Alright, this tells us this is here 6.51699. This is here f of 5, this function they gave us at 5. And given this, we know this is the total, that's the area. So if okay, yeah, if height is increasing at a rate of, so the height is increasing at a rate of 0.26, and the area is this, that tells us that for every 1 over 0.26 seconds, or wait a minute, rate of 0.26, so, right, that tells us that, so this is, okay, this is in feet per second, this is in feet squared. If we multiply these together, then we get feet cubed per second, which is change volume, so 6 point, alright, I can use the answer feature on my calculator. Answer times 0.26 is 1.69442 feet cubed per second. That is the change in volume. Rate at which volume is changing per second. Okay. D is going to be the rate at which volume, so volume is changing at 1.69442 feet cubed per second when h equals 5. Alright, that looks good. So, when h is 5. Okay, so, yeah, we should probably come back to this just to be sure I didn't make some silly, careless mistake. Other than that, I'm feeling pretty confident about this. It seems like I drew my line not very straight because I deleted it with my straight line tool, straight rectangle delete tool. So let's redraw portions of this. Okay, and you know what? Actually, let's use the. Okay, let's actually indecisive. Let's keep this here, and then say that this is going to be our new workspace. We only have 2 questions here, so this is going to be where we write answers to for question 2, and this is going to be on the bottom of our workspace. The figure above shows the polar curves f of theta, r equals f of theta, and r equals g of theta. From theta from 0 to pi over 2, let r be the region in the first quadrant bounded by f of theta. Okay, so r is this little curve here, and s be the region bounded by the curve. Okay, so s is bounded by f, g, and the x-axis. So it's not the entire area, it's just this little area between r and the curve of f and the curve of g. Okay, find the area of r. So first off, what we're doing is we got to find the integral here. So let me just write the 2. So we got to find the integral from 0 to 2 pi, from 0 to pi over 2 of 1/2, we're doing little triangles, 1/2, if we're doing the area of r, we just have f of theta squared d theta. So let me calculate this on the calculator. So integral from 0 to pi divided by 2 of 0.5 times, and now, alright, f of theta is 1 plus the sine of theta, which I'm going to call x, 1 plus the sine of x times cosine 2x dx. And this comes out to approximately equal 0.618731. So, part A is that let's get a nice color, area of R approximately equals 0.618731. Perfect. Okay. Let's get B. Alright. And also going to erase all of this. Maybe need some more precision erasing, so I'm going to use my actual eraser, which looks like it almost worked, but then I deleted part of this. So let's do that better. Alright. B. The ray theta equals k, so now we just have a line. The ray theta equals k, so you have some angle, where k is between 0 and 2 pi, divides S into two regions of equal area. Right, but do not solve an equation involving one or more integrals whose solution gives the value of k. Okay, so it divides S into two equal. So that tells us that the integral from 0 to pi divided by 2. So we're trying to find the region above k and below k. So actually, what we're trying to say is so the integral from 0 to k of, and now we got to find the area of S. So the area of S is going to be, well, g of theta is always greater than f of theta, so we're going to be saying g, so 1/2 times g of theta squared, which is 2 cosine of theta squared. But then we also have to subtract the area of R, so the area from 0 to k of 1 plus the sine of theta times the cosine of 2 theta d theta, and this is also d theta squared. This equals 1/2 times from k to pi over 2 of, same thing, 2 cosine of theta squared d theta. I don't know how we're going to fit this into that tiny area. Minus 1/2 times the integral from 0 to k of 1 plus the sine of theta times the cosine of 2 theta squared d theta. Okay. Yeah, let's try to squeeze this all into an integral. So, just a couple integrals. So, what we can do here is we can say, so we can factor out 1/2 from everything, get rid of all 1/2s. All 1/2s may die. And we can say that the integral from 0 to k of 2 times the cosine of theta squared minus 1 plus sine of theta cosine of 2 theta squared d theta. This has to equal the integral from k to pi over 2 of the same exact thing. So 2 cosine of theta squared minus 1 plus the sine of theta, monotony, cosine of 2 theta squared d theta. And what this is saying is the area below 1/2 must precisely equal the area above the 1/2. Yeah, okay. Kinda gross, but that should get the job done. Glad they asked us to not solve it. That would be annoying. Alright. Now, let's get to question C. For each theta, theta between 0 and 2 pi, let w of theta be the distance between the points with polar coordinates f of theta, theta. So, going out f of theta, theta, and g of theta. Okay, so basically, f of theta minus g of theta. So, write an expression for w of theta. Okay, so, first of all, w of theta. Now, here's the trick. You could do loads of stuff with square roots and weird sines and cosines, but really, it's just going out f of theta, going out g of theta. So what it's really saying is, and remember, g of theta is always greater than f of theta. It's just saying g of theta minus f of theta, the difference between them. Thank goodness for that. Write an expression for w theta. We just did that. Find w theta, the average value of w theta over the interval theta between 0 and 2 pi. So the average here is going to be 1 divided by pi over 2, which is the same actually as just 2 divided by pi, because that is the area we're doing this over, the domain we're doing it over. So from 0 to pi over 2 of this w of theta. So g of theta minus f of theta. So g of theta minus f of theta d theta. They actually want us to calculate this. Okay, so we're going to be whipping out the calculator. So the integral from 0 to pi over 2. Okay, g of theta, 2 cosine theta. Okay, I'm going to be replacing thetas with x's. Minus f of theta, minus 1 minus the sine of theta, sine of x, times the cosine of 2x dx. Okay, so yeah, that is that number, and then we take that plane integral and multiply it by 2 divided by pi. 2 divided by pi, and we get this number, which is, alright, so alright, let's write this out. So w of theta equals g of theta minus f of theta, and w average equals 2 divided by pi times the integral of 0 to pi over 2 of g of theta minus f of theta d theta minus, or sorry, which equals, alright, and this is the value we just got. So 0.309045 a dot. Okay. Yeah, that looks good also, because it's like right here it's pulling it down, right here it's pulling it up. It's 0.3. It's like approximately a third. Alright, so common sense check. Got that down. Looks like D is going to be an explanatory question, so brace yourselves. Okay. Question D. Using the information in part C, find the value of theta for which w theta equals WA. Is the function w theta increasing or decreasing at that value theta? Alright, so basically we're trying to find the value where now w of theta equals 0.309. So we're trying to find that, which is going to tell us, alright, you know what? Alright, let's write it down quickly and then use the calculator to solve it. So g of theta is going to be 2 cosine of theta minus 1 minus the sine of theta cosine of 2 theta. Just writing quickly here, save time. Alright, this is going to equal 0.3090545, blah blah blah, Okay, so if we do zeros, this is going to be the same as finding the 0 of 2 times the cosine of x minus 1 minus sine of x times the cosine of 2x. Okay, and minus, and just to make it a 0, I'm subtracting the 0.309 term. So subtracting this, putting it on this side. So we're going to say minus 0. And then that WA 309045, giving the variable x. Calculating. Okay, we get a list of numbers. Perfect. So find the value of theta. So again, we're looking for this between theta equals 0 and theta is 2 pi, which is 0.77 or so. So we're looking for it between 0 and 0.77, and as it seems, the only value for which that is true is theta. So this implies theta equals this 1.36173. ... Okay, well, given that, we say, okay, so we say W of theta equals W of A implies that theta equals 1.36173. Perfect. Now we have that. Give a is the function W of theta increasing or decreasing at that value of theta? Okay, so why do we have to give a reason for the answer? This is the calculator portion, dude. Just plug and chug. Anyway, we'll see. So if we find the derivative, now in the actual free response question section, you would have all your work still be there for the person who's going to be grading it. But for this special online free response question, digital, I'm going to be deleting things as I go, but I'm going to leave the final thing up so we can see it. So just we're going to say that W prime of theta, this is going to equal, so if we plug this into our derivative calculator, so the derivative with respect to x of 2 times the cosine of x minus 1 minus the sine of x times the cosine of 2x. Alright, if we plug this in, what do we get? We get this unfortunate number. Yeah, so alright. Now if we wanted to plug in a value of x at this, the value of x that, can I not plug things in? Oh, this calculator is so silly. Alright, so negative cosine, so the value we're trying to plug in here is 1.3617. Well, you know what? Alright. Let's not calculate this numerically. There's a smart way to do this. Numerical sucks. Whenever you can do something intuitively, that's best. W of theta is this difference. And right now we're saying that this difference equals the average at about 1.36. Well, 1.36, just using my calculator, 1.36 times 180 divided by pi is, oh, it calculated the silly cosine. 1.36 times 180 divided by pi, that's, it is not liking me today. Okay, here we go. 77 degrees. That means it's like right about here if you look at the line I'm making with my mouse, right? Is the distance between them increasing or decreasing? Clearly here it is decreasing. W of theta is decreasing the whole way. Sorry about that. W of theta is decreasing the entire time, except here where it's, actually it's always decreasing. So, what we say is W prime of theta, or we can say W of theta is decreasing. This is probably why they wanted a reason, because you can't really calculate it numerically very well, is decreasing at theta equals 0, sorry, I don't know why I keep doing 0, 1.36173, because it is it's not, I should use hyphen, but whatever, decreasing for all theta between 0 and 2 pi, or 2 pi over 2. And if you look at that, it makes sense, right? This is constantly getting closer and closer to it. It is, as theta goes up, you're never really, you never really have a value where it is increasing. So there you go. That is my reason. It might not be what they're looking for. We'll see. Okay, 2 minutes left. Let's check our answer from question 1. Perfect. Let's do that. So, all right. Very confident in my answer to B. Answer to A, let's just recheck that. Actually, you know what? Why did we even do that by hand? Let's just do it on the calculator. So 2 times 50.3, I'm recalculating part A, plus 3 times 14.4 plus 5, sorry, plus 5 times 6.5, 176.3. Okay, that's correct. Great. And units are indeed feet cubed. So, that's good. And then part B definitely is in overestimate. Okay. And explain reasoning. Yeah, that makes sense. Okay. C, I'm pretty sure I got an integral right. And D, water's pumped in the tank. Yeah, that generally makes sense, doesn't it? If, alright, so you have, I'll just quickly recalculate it. So you have 50.3 divided by e to the 0.2 times 5, all that, plus 5 still in the denominator, though. You get 6.51. That's the height. At that height, or sorry, that is the area at that height. And so you're saying you want to multiply the area by how much water you're pumping in to find the change in volume. So you want to multiply the answer by 0.26. Yeah, that's correct. Okay. Question 1 should be 100% correct. Question 2. All right, B. Okay. Well, A. Why not? Let's recalculate A. So the integral from 0 to pi. It's recalculating 2A. Pi divided by 2 of 1 plus the. Oops, not 13. Of 1 plus the sine of x times the cosine of 2x dx. 1 point. Oh boy, that's. Oh. Wait. Oh no. I'm not going to be able to do it. I forgot to square it and multiply it by 1/2, but I think I did in the actual answer. Alright, well, there goes the second. I forgot to do it in the check. Anyway, sometimes your checks are wrong. That's another good lesson. Sometimes when you're checking something, you actually do it wrong on the check. So be sure that your check is right if you're going to change based on your check. Alright, so let's go ahead and grade this. I hope actually that they have. No, they don't actually have the answers here. So here, give me a second. I'm going to go try to find the answers for the 2017 fee response questions. Be right back. So we can grade it. Be right back. Aha! Welcome back. I have the scoring guidelines here. So let us go ahead and score ourselves with the bright magenta that seems to be what we're doing here. So, first of all, the left Riemann sum, and again, on the actual FRQs, you would have all your work. So I don't actually have all the work. I'm just going to try my best to remember and score myself fairly. But you do remember that we had this left Riemann sum where we were doing 2 times A0, blah, blah, blah. So this 2 times 50.3 plus 3 times 14.4. So I'm going to give myself the point for the left Riemann sum because I did that correctly. And if it was on paper, I would have kept it down. So that means, so let's keep track of this in 2 places. So we have question 1. So we have A, B, C, and D. And then we have question 2 with A, B, C, and D. And this is how I'm going to keep score. So question 1A gets plus 2 for both the left Riemann sum. And then if you can see here, it's kind of small. I'm going to maybe even try to zoom in a little bit more here. As you can see, we have 173 cubic feet as they wanted. So we have 173 cubic feet. Okay, and now part B. Our approximation in part A is an overestimate because the left Riemann sum is being used and A is decreasing. And what do we say? Our approximation is an overestimate because the area A of H is decreasing and we're using a left Riemann sum. We reverse the order of what they were looking for, but yes, overestimate with reason. I say that is reason to give plus 1 point. Ha ha ha, not. Okay, so, sorry for my bad puns. Alright, here we have integral. So, again, this would all be written down if I hadn't had to delete it, but the integral from 0 to 10 of f of h dh, 101.325, I believe we got that right, cubic feet. ft cubed, same thing, plus 2. Great. And finally, the gauntlet. So, using this model, find this. So, the integral here, so, okay, I don't quite remember if I wrote it down exactly like this. We need the derivative of the derivative of volume times the derivative of h, so change in volume times change in height. But that's what we did at h equals 5, so I don't know how to score myself on that one. This is one of those where I'd give myself full points, but I don't know if an exam writer would. And again, if this was on paper, probably I would have written it down. So, edging towards giving myself a bit of a rosy picture, I'm going to give myself the 2 points there for dv dt, because I did use dv dt, even if I didn't write it exactly as I did. I did write down dv dt at the very least, and I guess they wanted to expand it out as integral. Anyway, so then we do indeed get the correct answer. We multiply by 0.26, and we get 1.6944. Yeah, okay. So, at the risk of being a bit rosy, I'm going to give myself all points for that question. And they say when h equals 5, the volume of water is changing at a rate of 1.694 cubic feet per minute. Yeah, that's perfectly good. Okay. So, on to question 2. Question 1 went well. Question 2, I think, went equally well, but let's see. All right, part A, they just ask you to get the integral right and get the answer right, and, well, we got both right. So, oh, wait a minute. Did we? We didn't. Or did I not write it down right? Wait a minute. Oh boy. They say 0.648. 648414. I say 0.648. That's different. Let me actually plug this into my calculator really quickly right now, just to see what happened. So the integral from 0 to pi, oops, wrong part. Integral from 0 to pi divided by 2, because they got something different than I did, but it's very close, which leads me to suspicion of, it's possible I forgot to square it. That would have been really silly if I forgot to square it. It's wrong nonetheless, but I just want to see. Of sine x times the cosine of 2x, and I'm actually going to square it this time to see if that's going to be correct. Yeah, it's slightly different. Now, if I get rid of the square, I betcha that it will not be happy about it. So, is there any way for me to copy an expression down? Maybe not. I'm just gonna, yeah, anyway. So, key lesson, make sure you're typing integrals in right, because otherwise you might get these simple questions wrong, and I'm sure, I don't know, I'm just gonna give myself 0 points for that. Plus 0. Wah wah. Okay, so here we have part B. So it gives us multiple options. Either we can have, so either we have g of theta squared minus f of theta squared d theta equals 1/2 times, so from 0 to k, and then 0 to pi over 2, 1/2 of that. Or we would go from 0 to k, k to 1/2. So this is basically saying it's just 1/2, same thing. So we did the latter here. We did from 0 to k, and then from k to pi over 2, and same thing, really, except we plugged in these. So I guess that's a lesson. We don't have to actually plug these in. It would just save us time if we hadn't, but it is the same idea, so it is what counts. So I believe that warrants a plus 2 points. Okay. W of t equals, so w of theta, g of theta minus f of theta, so that's plus 1 point. It does look like our integral is flawed, though. Now, I do believe that we got the correct integral, but the average value that we got is incorrect for some reason, which is odd to me. But so I'm going to give myself plus 2 points here because we did use the correct integral. I want to reevaluate that integral, see what might have gone wrong, because we definitely did this. We definitely said from 0 to pi over 2 of w theta d theta, and then divided by pi over 2. And we got something relatively close. I'm going to pause the video and calculate that. Bear back. Yeah, so indeed, when I do run it through this exact same integral, I get the same thing. What I believe may have happened is that I may have done the division incorrectly. So, actually, you know what? If I look up in my calculator history, I bet I can actually find where I was doing this and find where I get my mistake. So actually, yeah, let me pause. I'm going to look up in my calculator history to see what I multiplied it by to see where the mistake came in. So be right back. Well, folks, I don't believe it. I made quite a silly mistake here. I said that W of A equals this, and then in the calculator, multiplied it by 2 divided by pi, got presumably the correct answer, and then multiplied it by 2 divided by pi again, which is why 0.309045 times pi divided by 2 equals the correct answer. Much silliness is abound, folks. Well, okay. That's fine. It probably means our answers in part D are going to be incorrect, though, which is sad. Solves W of theta equals theta. Yeah. So that's obviously going to be different. I'm going to see, though, if they still reward points for solving it for your answer, be it incorrect. So, but for now, let's just see. And, of course, so the reason they're looking for is just that the derivative is less than 0. I find that quite odd. I mean, we gave more in-depth reason. It's decreasing always, so whatever. Sure, same thing. So we do not get the correct part there. So we get one part. Although, let me check if we get it for still doing the correct work, even if it's on an incorrect answer. I'll check that. Alright, there's nothing in about getting points if you do the correct work on an answer you got wrong in the previous part of the question. So we're going to give me 1 point for a good explanation. And that's going to wrap it up. So that means, okay, just reflecting on my experience here in this free response question and also in the previous multiple choice, I have got to work out my calculator. Just play around with it a bit, get to know it, because there are some quirks that make it a little hard to use. Other than that, though, did quite well. We got the first question perfect. The second question we missed 4 points in, which means that it's equivalent to getting 7 on each question, which is about what I tend to average. It is what I tend to average. And so, yeah, with that, I guess no careless mistakes. We could have gotten that point if I hadn't multiplied by pi divided by 2 again. So, yeah, I'll try to avoid careless mistakes on the no calculator section that's coming up, and I will see you then. See you.